I'm an independent contractor working with YLD, and we have been in a client working with Tauri to build an app for writing text, and with AI, and the requirements were such that we had to write a desktop app, multi-platform. So we got into Tauri through that. So, and this talk is about in a way, our experience and allow you to know what we can do with Tauri and take advantage of Rust, as we saw in the other talks. So my idea is to share, in a way, again, sorry for that, given the previous talk, what are the main goals or the main characteristics you're going to get using Tauri as a platform, and then some features you can use in Tauri, and a demo with code to feel how it looks. So Tauri is an open source, free for use framework. Someone asked, yeah, this is free. Designed to build cross-platform desktop applications. It's not actually only desktop, it's to build applications, even without UI, I would say, to a certain point. And the key features that they recognize are being flexible, fast, lightweight, secure, and cross-platform. So now what this means. So what is being flexible? So being flexible is being agnostic of what you're going to choose to build the app. Of course, there is a strong Rust baseline, but after that, you can choose for the front end, known technologies from the website based in JavaScript, using web technologies, even WebAssembly, for example, and or even Rust. So there is a lot of flexibility on that side, and also advantage because you can take advantage of knowing such technologies, so that you can use your preferred tools to work with Tauri, adapting to the project requirements, etc. So it's good for that. In terms of being fast, so I think that's in a way no-brainer given what we spoke. Yes, Rust is maybe the faster on the market currently, and that's also the way they built Tauri, the tooling around the building process. You're going to see aspects from the way we opt in for using certain features. It makes it faster because the footprint is smaller, hence faster, and with other advantages. And also, as was mentioned before, the benefits of, for example, zero-cost abstractions, so that you can be on the edge of the performance, because those abstractions now have zero cost for you when running the code. In terms of the UI-facing side, and if you think about other competitors like Electron, what they say is that they can provide a faster solution in a way that they use the native web render for the browsing capabilities. The third characteristic is being lightweight. So being lightweight is very important for an app. For everything, even for the web, we know we are always trying to shrink, to minimize, to ensure that the images have the threshold right between the accuracy and the size. And Tauri makes a huge effort on producing such binaries, very small. We're going to see what's the size of an app. That can be huge as you want, because you can embed other libraries or other tools inside your deployable, but you can get like an app in 600K, okay, below 1 megabit. I won't show that one because you need to activate certain elements and the app needs to be reasonably simple, but the baseline is quite small. So you would think, I don't know, like comparing with Electron, that you get more than like around 100 megas, just baseline because of the way they built. I don't want to go to that point because they have their reasons, but we're going to see like 5 megabytes for these. And that's important when you think about an app that's going to be downloaded, going to be updated, and therefore, if you reach a massive audience and you store these in a storage, you're going to pay for the download size, most likely, and that can become an issue. It was actually, there are stories about that. Not for Tauri, but for other projects where they got viral and they got issues paying for the traffic in the storage. So we can do that by optimizing the compilation of application features. Okay, and we're going to select opt-in for certain features, and that would make taking advantage of Rust compiler, that amazing compiler and the ecosystem, making this most lightweight, smaller application. And also again, the not having to also deploy the browser or the web render, it's a big deal because you don't need to send those bytes and it's going to be updated, etc. By the operating system. Security, it's always important, right? It's everywhere, and this is front of mind for the Tauri team. They do use Rust, and Rust has, as we saw, like for threading, for memory allocation, sharing data, etc. It's safe, like bird design, I would say. The code itself, and you're going to see, if I try to access the file system, error. If I try to open a model, error. So it's secure by default. So you need to be explicit on your intentions, even to go browse and do a HTTP request. You need to explicitly say which APIs, let's say you have an external API, you're going to use. The communication, so there is like the backend in the front-end concept in Tauri. So the backend is the Rust code that it's kind of your goal, because if you are using Rust and Tauri with Rust, one of the goals is having certain parts of the code that have requirements for the performance, or maybe a system call, etc. So that part needs to communicate with it's called the front end, the user interface. And the communication between these two worlds, most likely you're going to use web technologies for the front end and Rust for the back end. It needs to be secured. And it's quite simple. It's a message passing technique where you need to serialize the payloads of the request and the response, but it's effective and it's secure. That's what's important. Also, I think it makes sense to say that they are conscious of making security audits for their code base, horizontal, where they test all the libraries that they use, and also vertical to see penetration errors, etc., by external teams, and they publish the results. Finally, being cross-platform. I think every time we want to build something that we're going to show to everyone, if they have Linux, Windows, or Mac OS, in the future, supporting also Android and iOS, those devices. So it's not only desktop. So currently, Tauri is on version 1.6, I guess. It's 1X. They are working very hard on the version 2. There is an alpha channel on the version 18, I think, or something like that, for a long time that you can opt in and use right now. And they are actively supporting to, working to support Android and iOS. And it's quite simple. There are some challenges for like, oh, what you're going to use as like the bridge for existing code. Yeah, Kotlin mostly for Android would be nice, or Swift for iOS. They are also working on that part, okay? Moreover, there is like a company, Crag Nebula, that is that was made by the core developers. So they joined forces and they created this company that is even making Tauri stronger in a way that they would provide services for deploying apps, to sign apps, etc. Also, like with the business model, then you're going to pay for their services, but maybe there is the right trade-off for like indie developers to build their apps as fast as we can build in Tauri, because that's very important, I guess. I think it's the most important part of Tauri. Comparing with Electron, I tried. I'm not that young, not that easy for me to try stuff as before, honestly. So kind of reading through the ecosystem of Electron and doing stuff, maybe it's not something I liked, but for Tauri and with Rust, it's super easy. And it felt very well. I kind of, after preparing this, now I want to do Tauri apps to learn Rust also, because my background is also in C. I was sharing that with Miguel before today. So maybe you also are with this mindset, like, oh, let me try Rust through the UI, because I'm a UI person and I want to see like interactions, not through the command line, for example. So these are the main core features of Tauri. The architecture is super simple. I just copied this from their website. It's just to say that they have like these three main parts, the core, the RAI, and the TAO. So, and the Tauri core is like the, oops, I have something. It manages the execution of the application. It's like the platform and connects everything together and handles the interaction with the system-specific parts that need to be implemented by for the different platforms, like the window management. You can guess that they are different across Linux, all the Linux variations, and also the web OS, sorry, the Mac OS, and all the others. And that interaction needs to be done by someone. It's done through Tauri core into the next topic, that is the RAI. It's so difficult to say this. I don't even know if this is the acronym for Web Rendering Library. Maybe not, because the TAO is not such an acronym. But it's a library they have. It's the abstraction layer for just pointing and like adapting the web view, because we know there is like, when in the front end I want to invoke Rust, I'm in the web view space. So we need to augment the environment, the JavaScript execution, to be able to interact like with Tauri. And also the wrapper around this is the TAO. The TAO is just, it's another library built on top of existing code, proved like Winit, and they extend with a menu bar and system tray, because some systems don't even need to deal with menu bars and system trays, so they have had to implement that. So these three elements you generally don't need to care about. So, and that's very good about the Tauri system. Maybe if you build it the last time, you're going to read this, otherwise in the documentation. So let's go to features. I'm almost there. Next slide is about demo. So before that, so what can we build? Which features Tauri offers? Everything you would expect maybe sometimes you won't get what you want. I will explain in a bit. So what can we get? Self-update, very important nowadays for the app. Okay, the web is always updated, but the desktops aren't. So there is a mechanism for that. Plugins, because yes, we're going to share code, and code that is Rust code that has like to interact with Tauri in a certain way. So like think about authentication and authorization. For that they have, for example, a plugin, an event system, so that you can also receive in the front end notifications from what's happening in the back end. For example, think about the back end as when you go to a menu and you click something, that's an interaction that comes from the back end in a way. And all other aspects you can do with the events, because they are multi-producer, multi-consumer, and they work across the two spaces, front end and back end. Then application icons, yes, they have a solution. You just need to upload something that is very simple, but if you think of application dimensions, different sizes, etc., they can build that for you. You just give an icon, and they produce all the variations that are required for the application icon. Yes, we can have multi-windows. So I'm going through these from left to right, top to bottom. Multi-windows, you can open different windows, manage those windows. You can have then window API with the borderless and everything related with Windows, including the menu. Okay, configuring new entries. We're going to try that. We need to write Rust code in version 1 for that. So that's why I have this paper. I think it will be fine. And application tray, because your application can live in the tray and be very useful, because taking advantage of global shortcuts like command space, that's an application in a way. Like, yeah, we can, I think, even replace this in Mac. Also splash screen, so that you can see something while the application is still loading. File system that is scoped. So again, security concerns. Application storage that is also platform aware, because where you save temporary files in Windows and Linux-based systems or macOS, it's completely different, but we can access agnostically to those for sure, because otherwise it won't be platform agnostic in a way. And also notifications, a sidecar pattern, maybe you don't know what this is, it's very important. It's being able to embed in your application a different application. For example, going back to the example for RevStudio, RevStudio is the application we implemented. With this, we've added like a data engineer that was working with the AI. That's normal, having to write in Python. So how can we join these two worlds? Okay, we can have a Python script, a Python application that we bundle inside, and we use the sidecar pattern to call that application. Okay, we have multiple ways of controlling the life cycle of these applications, etc. So that's using the sidecar pattern and in a way the commands API. The invoke API, it's for calling from the front end the back end. That's going to be in the demo right away. So I will speak more about that in a second. And also even command line applications, there is support, among others, that you will find. I think this is just, it is already a long list. So let's do some code. Yeah. Okay, I think I can call these. So in the terminal, you can see these on the, first you need to install the prerequisites, like Rust and other like X, if you are in the system, X code tools, etc. But after that, you can use yard, for example, create, and Tauri app, and it will create, it can be also with the npx. Ignore this is my machine, you shouldn't have these errors, but they are like, this is optional, don't worry. It's working, it's gonna work. So let's give it a name. So LX, to be short. Then we can choose in this interactive way, if we want to go wild and use Rust all the way, I want, or TypeScript, JavaScript. So for that, I'm gonna choose, we don't care actually. So it's Yarn, and here to be a bit more advanced, let's say React with TypeScript. It's okay, so that we have more code. So what the tool did, created a skeleton of the project. So we can go to the LX, and we can code these. Is size okay? Okay, so the app is super simple with like scripts to start the app, as you would expect, like in a web-friendly project, you would see package.json with the scripts to start. The most important is Tauri. That is a gateway to the Tauri command line script to build, to start the development server or development mode, and also some dependencies, also for TypeScript. And then you have these two folders that are the important folders with the code for Rust, source Tauri, and the source is the source for your UI. I think they should have decided to use source UI and source Tauri or backend, but it's okay also. So you will find this super simple code in Rust. So it's the main, standard main to spin the app. So it will build the Tauri app, telling him that we have a command named greet, and you will run the app. So it will show the app. So this is making, using the macro Tauri command. Yeah, and the documentation in Rust is quite amazing. And you have like a function that receives a name and produces a string. And we are just returning these formatted. So we don't need to return, you just need to not use semicolon in here. So this is the backend code for now. So we will be able to call in a way to invoke greet and get like a welcome. So let's run this before showing more code. So yarn install, let's not forget that. I keep forgetting these. And then yarn Tauri. Yeah, I'm using my phone or the Wi-Fi. Yeah. I thought this would be faster. Maybe PNPM would have been. Okay, I know. Yeah. So yarn Tauri, you can always. Oh, sorry, my keyboard. Yarn Tauri, sorry, help, and you can see what you can do. Like for example, icon, so that you can build the icon. But why we want to have to run dev. So here we go. We are in development mode, compiling. Yes, this will take, for a good reason, it will take time. Even in dev mode, we need to have Rust code, and it's the first time. It won't happen always, okay? So, and it's gonna be quite fast, as you see. So this is the app. This is what you're gonna see, and it's super easy, right? HTML with React, a button, and you click, and you're gonna get like Carlos, enter, hey Carlos. So as you might guess, this is coming from the Rest side. So let's see how that happens. So that happens very easily. So if you go to source, it's super simple to files. The main, that is nothing. It's just a wrapper for the app. And then the app itself, it's bigger than it should in a way, also because of my font size. So we have a form with an input and a button that when you submit the form, you greet. What is this? It's setting the state with the invoke. So this is the part, the glue, calling the backend. So I will make it extract to enclosing scope message. Oh, and now it's complaining about typing, okay? So what's happening here? So, and we spoke kind of in the other discussions about this type safety, and we are calling the backend. Yes, we are in TypeScript, but we don't have magic. And maybe there are tools that I don't know, they should exist, where we can define like a process where we create TypeScript definitions for invoke, okay? In our project, we used when we were calling the sidecar, the code in Python had a structure, like a proper structure, and we generated TypeScript definitions and a wrapper with generics so that we can not use strings for this, so that we have like a method called greet with parameter name that's super easy to build in your app. So that's kind of a non-issue. What you need to do is know what you are doing, and for example here, doing these. Okay, but this isn't that important. What we need to understand is that we are calling invoke from a JavaScript library that Tauri provides and we can use, okay? So if we want to use different things, or even let's create quickly in Rust a different comment. We just need to create a comment. Let's call it like power of 2. We can even use this num, that is a number, and we going to return a number. And we have, oh, sorry. I'm thinking too much with my keyboard. Yeah, my keyboard is in English and I'm typing in Portuguese. It's always a mess. And I use an external keyboard. So yeah, the code is running. So it should be fine, as he mentioned. So my code, I think this should be the way we do exponents in Rust. We just need to make sure that we use that library, that function. We expose to the calling party. So we do this. So we just need to state that they exist, okay? And let's transform these in that code. So instead of the greet message, what can we do? Like let's input a number there. Maybe we can input a number. And here we call, instead of this, power of 2, for example. Underscore? Yeah, with an underscore. Okay? So you're going to find, thank you, I'm going to make another mistake. So this is a string. Let's see if this works. Oh, by the way, I didn't recompile. So I didn't, because all the things you would expect from a modern platform, let's say, developer experience, it's implemented. So hot reloading for the web without Rust having to reload. And also, if you change the Rust side, you would make these, like the app restart automatically. So 3, we call greet and we got error. So we got an error, or this isn't working, okay? So can we know what's going on? Yes, so we just need to inspect element, and don't forget we are like in the web, in a way, inside an app. So you have all these tools for your use. So unhandled promise rejection, yeah, invalid arg num. So the first error is actually I'm using name, and I shouldn't use that because the specification is like to use num, that is a number, okay? So let's use num from a name. Sorry, this code is quite bad, but. And now what can we do? Did I forget anything? You see? So even with this, I'm getting an error of giving a string. So there is some contract, some type safety, even with this light protocol of message passing, okay? So they understand objects, and basically JSON, I would say, in a light way, okay? So let's make these with a parse int. Maybe the worst code I did so far. And we have 0. Amazing. I'm not the best.
It's returned.
We need to return? What? It's right? Is this the power?
That's short.
What?
That's
Sure, right? Okay. Returns power. So wait, I have Copilot. So it's restarting, and now it should work. Yeah, that was. And actually, yeah, as I joke, Copilot is good for this. You are, I don't know, and if you say what you're gonna want to get, you can do this. So I think we are kind of over time.
Yes.
So sorry not having more to show, but yeah.
We have time for one question. So, hands raised. Okay. I'll make my question then. Can you compile to mobile?
Can Tauri Rust? Yeah, yes. Not in this version. So I mean version 1.6, 1x. But in the next version, you can just like yarn create Tauri apps minus alpha, something like that. It's very easy to find also in the documentation. And then you can target to a mobile.
Okay, thank you. Okay, I guess one question.
Yeah, good question.
Since it's not from me.
Yeah, just regarding the declaration of the function that you create in Rust and then you were using in React. Do you need to use like the same name of the argument? Like in this case, you use num. Do you use
exactly the same name, and that's quite annoying. But I think it's only annoying when you are starting, because as you build an app with a capital A, you're gonna need to build tooling that generates code that connects these two worlds.
You just need to look at the fact that you're passing it an object.
Yeah, it's an object.
Argument. So if you're passing an object, you need to match the order of the arguments.
Yeah.
And also because for TypeScript, it's easier to type check.
Type check on a type with the structure of the payload than like on arguments, floating arguments in the function declaration.
But Tauri can definitely improve on the type errors within the code editor in there.
Yes. Yeah. But you got very good
Yeah.
errors, right?
Yeah.
In the from the backend, so it was quite amazing.
Right. Thank you very much, Carlos, for your presentation.